Well, good morning and good afternoon, everyone, depending where you are in the world. Thanks for joining this webinar, where today I'll be going over some of the georeferencing workflows and products we have for the mining industry. Just to introduce myself, so my name is Owen Howells. I'm the Senior Solutions Architect for mining. My email is up there. So if you have any questions or anything like that, please feel free to send me an email. I'll be hosting it by myself today. So I look after the mining side for GeoSLAM. I try and manage all the workflows, understand the customer's needs. If anybody has any questions about anything, even if it doesn't even if it's not related to georeferencing, any kind of mining products we have, please feel free to send over an email, or any general inquiries, please send an email to info@geoslam.com. So the agenda today, first of all, I'll go over a little bit of the background of GeoSLAM, who we are, what we do, how do we do it. And then I will also be touching on some of the main workflows we have for GeoSLAM mining. This is in the series of webinars. We have had a couple of webinars before, and we've got a few more webinars coming up on mining and on other related subjects as well. So please keep an eye on GeoSLAM's social media, where we'll be spreading the word of the different products and the new softwares and equipment that we're releasing soon. It's quite exciting times here at GeoSLAM. We're working on a lot of different projects at the moment, and there's a couple of snippets in this presentation where I will show some of the new workflows and softwares that we're looking on. Then we'll be going on to the georeferencing. First of all, with GPS, and then obviously then without GPS. I'll be highlighting how GeoSLAM Connect will help automate a lot of these processes, and then a quick summary at the end. If you have any questions in the little interface that you have from GoToWebinar, it does have a little box in there where you can ask questions. I'll try and answer all these questions at the end. This shouldn't go the full hour. It depends how difficult the questions you ask. But this is quite a short, sharp webinar where I'll try and go over the main points with you. So I will be trying to answer all the questions at the end, but feel free to ask them at any point and we'll get through to them at the end. So just a quick background about GeoSLAM. Located in the UK, that's where I'm based as well. I'm based in the headquarters here in Nottingham. We have got a global network of offices and dealers. And what we're trying to achieve, we're trying to bring technology to people who really need to understand the environment around them. There's so many different methods of collecting data these days, but we're trying to be the simplest, the fastest, and we're really trying to push the boundaries of what geospatial data we can get from the environment around us, and in the methods that we collect it as well. So in short, we're trying to be the smart way to map and understand spaces. We have quite an interesting history. We set up back in 2011, and we were the first company to commercialize SLAM. We were the first kids on the block, so to speak. There's quite a few companies now who focus mainly on SLAM, but we were kind of the first there. So it kind of goes hand in hand with saying that we've got the best experience in the business. We've got quite an open mind to trying to solve complex issues. So if you have the kind of site where you think they can't solve our issues because of reason X, Y, and Z, we'll give it a good go, where we like to try and adapt our technology to try and fix these complex problems. And this is why we're the market leaders at the moment for SLAM mapping. These core values, this is what I will refer back to every time. And I'm sure even if you don't know much about SLAM, or if you do, you should know there are certain elements of survey and capturing geospatial data where we could improve on at least 2 of these every time. So these 4 core values I've got on the screen now is something where I will jump back to at all times. We're trying and focus on the speed of capture, a simple workflow, a means of obtaining the best kind of business intelligence, and trying to make the process as automated as possible. So I just want to cover the basics, just in case there are people here who don't really understand what SLAM is and what do we do. So GeoSLAM, the SLAM means something: simultaneous localization and mapping. So with our software, we try and basically, when we're in an environment, we have to locate ourselves within the environment. And then as we move through that environment, we have to map what's around us. So it's a very complex algorithm. We're a LiDAR based system. So LiDAR is light detection and ranging. LiDAR utilizes a laser sensor, and we spin that laser sensor around so we can collect all the data around us, so we can locate where we are in the environment around us. What we also do then, we have an inertia measuring unit, an IMU on board, which detects any changes in the movement of this sensor. So using those 2 data streams, we can map a whole area around us. It is that simple. So our SLAM, since 2011, we've always strived to work hard to improve the SLAM, but there's other features around the SLAM that makes it a very, very good product that we have. It's the interface that you bring the data into and process it. It's the actual deliverable of data at the end, and the hardware as well. All of these come together to create the product that we offer today, where we really have worked hard to try and get the best possible product to where it needs to be and out there collecting the data, all you guys out there around the world. So like I mentioned, this webinar is part of the GeoSLAM mining series of webinars. Before now, we've looked at a couple of specific workflows to do with volumetric data, mining in general. We also done a joint webinar with Micromine showing how data can be best utilized in that. And this is just a quick snippet of some of the customers who have invested in our products over the past few years. Like, as you can imagine, the list is actually a lot longer. But interestingly, although we work in construction, agriculture, real estate, mining is our biggest market, and it's always been up there. It's always been one of our biggest markets, and it continues to grow. We're seeing a massive appetite at the moment for this kind of modern technology, just because it's so fast and so easy to use. So like I said, these are some of the reasons why people like using SLAM. So SLAM is totally mobile. It's in your hand. You walk around. It's really light, really portable. On the screen here, it says over 10 times faster at acquiring data. That's compared to traditional methods using a terrestrial scanner, a tripod-mounted scanner, and it does not require GPS to work. That is critical because obviously us in the mining industry, a lot of underground work. So we need a system to collect this data nice and easy. on quite a rapid frame so we can get all this data to where it needs to be. So to kind of simplify that, this is exactly what I'm talking about. This is one of the mines in the UK who have a few, I think, a few of our scanners. So this is what the survey team do. This is how they collect the data without holding up production. Every week they have to go down and map all the mined areas. They don't want to hold up production, and they don't have any night shifts there. There's no lifts that go down in the night. So they need to collect the data as fast as possible in the mornings. So they literally turn on the scanner, turn it on, pick it up and walk around the heading. They can do the whole heading, or quite a few headings in one go. And this is just what the data looks like. This is captured just by walking around the scene here in this mine. As you can see, it's a nice clean point cloud, and this can be very, very useful if it's used in the right way. So this is something that GeoSLAM are working hard to achieve. We want to supply this data every time in a fast method of collection. We want it to be very simple. It's a one-button operation, but critically, this has to be georeferenced, and it has to be nice and clean, ready to go to be analyzed in other software packages, such as Deswix, your Micromines, your end software package. If we can provide a point cloud like this that's georeference cleaned every time, we will make the surveyors' jobs a lot easier. We will make the quality of data being delivered to mine management and the decision makers a lot better. And there's just a lot of benefits to be taken from using our equipment. Just to quickly go over the actual product family that we have. We have the ZEB Go, the ZEB Revo RT real time. We have the ZEB Horizon. So to go over these individual now, our ZEB Go, which is our entry level scanner, our one that'll probably cost you the least to purchase. We have a 30-meter range on that, IP65 protection class, and a 1 to 3 centimeter relative accuracy. So like that data I showed you, you just simply turn this on, walk around the heading, and you get a point cloud with 1 to 3 centimeter accuracy. The ZEB Revo RT real time. So this is one of our most popular scanners. Again, a 30-meter range, but this is a real-time processing unit. As you can see on the back of that unit, there's a tablet. And on that tablet, that will display the point cloud in real time as you're walking through. So this is really, really useful to understanding exactly what you're capturing. So as you're walking around, every step you take will be more and more data being displayed at that time on your tablet or phone. And then the ZEB Horizon. This is the most popular in the mining industry right now. We're having a lot of customers come in and asking just for this scanner. 100-meter range, that's the main reason they like it. And as well, we can read intensity on this. This will give a colorized point cloud as well using the ZEB cam. So it's a really, really handy scanner to have around, pardon the pun. So up there it says it has a relative accuracy of 1 to 3 centimeters. Now, recently, using some new filters that we're applying to the scanner and a better calibration technique, we've actually improved that to 6 millimeters. So our relative accuracy now is 6 millimeters using our new technology, our new filters, new calibration. This is what I was referring to earlier. We're always striving to improve how we're delivering our data. But another fantastic feature of the ZEB Horizon, as well as the ZEB Revos, but mainly for the ZEB Horizon, is its flexibility, where you can use it. So you can mount it on a drone, vehicle mount, a cradle to do shaft inspections. You can install a panoramic camera on it, pole mount it. You can even use even adopt our discovery module, which will fully colorize our point cloud if we want to map some geology or so forth. So, and on the bottom there, we've got the ZEB locate. I'm not going to talk too much about that now because I just want to mention that there's two main methods when it comes to actually georeferencing the data. I've spoken a lot about the different products we have, how we visualize the data coming into the mining data framework. But how do we georeference? This is why everyone's here today. So there are two main methods. The first method, in a GPS-enabled environment, an open pit mine, let's say, or somewhere where your stockpiles are, we can use the ZEB locate, which utilizes the ZEB horizon, as you can see. That's the handheld scanner that we simply just slot on the back of this backpack unit. And then on top of that backpack unit, we have our GPS receiver. We can just simply walk around an area then, and all the data we collect is georeferenced straight away using the GPS receiver. Nice, simple workflow. What's very handy about this product is it's very, very simple to use. There's no need for massive calculations of lever arms because it's a set offset there. When we start the scanner, it's completely independent from the GPS. What it does, it marries up the two trajectories from the GPS and one from the scanner, and that's how it basically georeferences the data. So that's a nice simple way of getting GPS enabled point clouds straight in to whatever data framework you have. But that's the simple way. Obviously, there has to be a difficult process for georeferencing underground because obviously we have to cater for GPS denied environments underground. So this is where adjust to control comes in. So adjust to control, we take advantage of being able to use external ground control points, and using those ground control points, we will calculate the transformation, and then we will then deliver a fully georeferenced point cloud in that using those control points. We do require the reference plate, like you see on the screen there, to be installed underneath the scanner. So it can be installed on any of our ZEB units, the ZEB Go, ZEB Revo RT, or the ZEB Horizon. And then we can look at two different types of transformations, which is non-rigid and rigid. To collect these reference points is quite simple. With the ZEB Revo RT, one thing we have to remember is the scanner has to be held upright at all times. It doesn't really understand its inclination at all times. So if we're going to georeference using adjust to control with a ZEB Go or ZEB Revo, it has to be held upright. However, with the ZEB Horizon, it can be in the side, it could be upside down. It understands its own orientation. So this is why a lot of mining customers, when they look at georeferencing data, they tend to adopt the ZEB Horizon. To show you how simple it is to collect these control points, using the base plate that's installed to the handle of the scanner, you just simply put it on the control point. So in this area, we just have simple survey pins, and we just match up that little star you see there that has the fixed offset from that reference point to the center of the scanner. That's all calculated for you. So we hold that on top of the control point for up to 5 to 10 seconds. That will drop a little marker on the trajectory saying The scan has been still here for 5 seconds, so I will drop a reference point here. What we then do in Hub 6.1 or later, so this is the earliest version that utilizes adjust to control, we then go through the adjust to control process, which is a really simple process of just assigning those points, those reference points in the scans, where we put the scanner down to for 5 to 10 seconds. We just give them their X, Y, and Z. It's a really, really nice, simple method. And then in Hub, when this is in and processed, we get a nice little report at the end with our RMS errors. So we can understand if there's too much error or we can recalculate it. Maybe a control point has been put in the wrong format. This will give a report on how accurate it is. And on the screen there, this is quite a large capture, but this is what it looks like when we have a lot of control points in the scan. So this will be a really, really accurate survey because there's so many control points. I will stress that we should have the minimum amount of 4 control points in a single scan. A scan could be up to about 20 minutes long capture time, so you can walk around for 20 minutes. But along that, we should look to get at least 4 control points, and they should have a nice even spread around the scan area. So like was briefly mentioned earlier, we have 2 types of transformations. We have a rigid transformation, which is just a single transform, and it does not change the scale factor. It quite literally rotates the scan and matches it to those control points without changing the scale. It's really simple, and it's a really, really effective way of getting our data georeferenced. However, to go to the next level, we can do a non-rigid adjustment. Now, non-rigid means that the data can be altered to suit these control points. These control points will help the SLAM process, and it'll be as another constraint to SLAM as well, which is very, very useful if we're working in an environment that isn't very SLAM friendly, so to speak. SLAM requires a lot of good features around it for it to constantly reference itself back to. If we don't have those strong features, or in another scenario, we cannot close the loop, which is start and stop in the same location. If we start at point A and finish at point B, that's called an open loop scan. We can use adjust to control non-rigid adjustment to help the SLAM recognize where it is. So it's a very, very handy thing to have as part of processing. And in some of the rare environments where SLAM does struggle, we can use adjust to control to correct the scan as we go. And obviously that'll be fully georeferenced then as well. So that is adjust to control in Hub 6.1. What we are going to start doing in the next couple of months is slowly migrate over to GeoSLAM Connect. GeoSLAM Connect is going to be our new module for processing data. And what it's going to help us do is provide a lot more of an automatic workflow for processing our raw GeoSLAM data. So the data will come straight from the scanner and then into Connect. We will have a set workflow then. If the scanner is doing the same job over and over, the GeoSLAM Connect will be able to automate a lot of these steps for us. So if we're just looking at delivering a georeference point cloud, we will use the adjust to control workflow in GeoSLAM Connect. We will bring the raw data in. We will load the control file, which will have the X, Y, and Z coordinates of all the control points in the mine. The software will be able to detect exactly which control points it needs using our constellation mapping algorithm, so it'll understand where these are set up spatially, and it'll match that automatically. So we could have a control file with hundreds and hundreds of X, Y, and Z, all the pickup points within the mine. And adjuster control in Connect will automatically detect which one it needs to, which points it needs to bring in to georeference the data. So we're really trying to automate all this. The workflow I showed you in Hub requires the user to import the exact coordinates of these X, Y, and Z points, where in this, that bit is automatically done using the mine's target control file. So it's a very, very nice way of getting this automated quickly. So also in Connect, I wanted to bring this in because this is something I really want to stress to our mining customers. We're trying to deliver for you guys a clean georeference point cloud. We recognize that a lot of softwares want these point clouds to be processed in the best possible way before coming into the CAD side, or before going to Deswix or your Micromine. It needs to be in the right format as well and in the right location. We've taken all this on board, so we can automatically georeference in Connect. We've also got a cropping tool. We've got a filter tool where we can classify points by range, elevation, intensity, outlier, surface noise. There's a lot we can do. And what we can also do then is set the workflow. Typically, it'll be, we will run the SLAM, run the adjuster control, and then run it through some of these surface filtering, thinning of the data. This data has to kind of be downsampled before going off to be processed in other softwares. What we've noticed is your SERPbacks, your Micromines and everything like that, they prefer our point clouds to be ready, and they prefer these point clouds to be downsampled. They prefer these point clouds to be cleaned before doing anything else. Their softwares are a lot better at analyzing the data if you were going to compare to your cloud compares and so forth. They are set up for analyzing the data. At GeoSLAM, we're trying to provide this data in the best possible version that we can. So we need it georeferenced, cleaned, and in the right format, in the right location, ready to go. Which goes on to our next point. We have already had customers set up a kind of workflow on the site for getting the data from the scan site straight through and processed. So the person up on the surface that's responsible for all the data analysis can have that point cloud sent to them an hour or so straight after it's been captured, sent over the mine's Wi-Fi or LTE network, and then on the cloud servers or the local cloud, we can have GeoSLAM Connect sitting there, which will run the SLAM algorithm, georeference, clean, and then put the data exactly where we need it. We're trying to cater for these kind of mines where your most senior staff who do more of the analytical work and the decision making. We're starting to realize these people don't tend to go underground much anymore. So if we can get the data capture nice and simple underground, we can process it all automatically in the middle. So the person on the surface in the office responsible for analyzing the data has this point cloud in the right format, cleaned, georeferenced, ready to go. So that was kind of a crash course in georeferencing our data and what Connect will do. I just wanted to go over a few things before we go on, just to kind of understand what are the kind of deliverables we can have if we do georeference our data. This is one example of one of our customers in Australia. All they want to do is compare ZEB Horizon data with the model. So this is georeference data. This has been cleaned. This has been downsampled, so it can be easily processed in this end software. So it's literally a point cloud that's ready to go to be compared. This is done in 3D Reshaper by the customer, and we can see the kind of deviation from the model here, which is quite effective. And this is something quite a lot of minds want to accomplish. This is only possible using adjuster control with GeoSLAM Connect. The automation of this is only possible with we're using these two. If we're not georeferencing the data, this won't align at all in any other way to the cloud. Even if you're using cloud-to-cloud registration, the clouds have to be in the exact kind of spatial format to run that. It has to have the right kind of decimation. There's a lot of variables going on there. We have to, in the mining industry, make sure this point cloud is georeferenced. Adjust to control is the answer to that. Nice and simple. Likewise, we can just bring the data in its the point cloud straight into mine planning softwares. We are working with Deswik, we are working with micromines just to get the right workflows out there for our customers. And we're open to working with other software providers. We just want to make sure the customer has the workflow and can accept the data. I really don't want customers feeling the need to manually crop data or manually process the data. I want to deliver this data to you in the right format, georeferenced, ready to go. And that's what GeoSLAM are working hard to achieve. Another quick example of what's possible in Connect is the ability to do simple cloud-to-cloud registration. Because I can import now 2 point clouds that are georeferenced, so geospatially in the right area, I can measure the change in between them. So blue here is no change, red is a lot of change. There's been a lot of excavations here as well and a bit of shotcrete applied. So it's probably not the best data set to show that much change. But I find it interesting how it's consistently picking up on the pipe on the right-hand side. We're having a bit of convergence in some places. This is enough of a deliverable to a geotech to go down and investigate the area. There's obviously going to be changes in the vent bag, but it's just a nice data example of some change we see in some headers. Most of the time it's not down to geology. Most of the time is somebody's backed their loader truck into the wrong piece of equipment that causes vent bags to collapse, or it's just a stockpile underground being shifted. So again, it's a nice clean point cloud that we're delivering here, georeference, and the red shows any changes. Another, I think, is a very useful adaptation to the software is the ability to extrapolate control points. I've seen this come up time and time again recently. And Mine Survey is one of those, I always try and recommend that the actual control points should be measured with a total station. And I do think that's where the control should come from. But in some areas, sometimes you just need a quick control point just to carry on with the advancement. So in this data example, it's quite a crude diagram, I accept that, but in these 3 locations, there'll be a known X, Y, and Z survey pin. So we could just hold the scanner up to those for 10 seconds. That'll drop the marker on it, and then we can put its true X, Y, and Z into it. But there are 5 control points picked up in this data set. And these other 2 control points have an unknown X, Y, and Z. Because we've georeferenced the data with the 3 known X, Y, and Z data, we can then extract the unknown control points from these other 2 areas where there is a survey pin, but it hasn't been referenced in yet with the total station. So there's another really useful way of using GeoSLAM Connect with adjust to control. Just to go over a couple of things to show what else GeoSLAM Connect can do utilizing adjust to control. We obviously do GeoSLAM volumes where we have a software that works with Connect, where we can automate the workflows for walking. We capture the data, simply walk around the stockpile, then an hour later you have your volume. We filtered out infrastructures such as roofs, conveyor belts, dozers sitting on top of a stockpile. That's all done automatically for us. We can provide a product to you where you simply walk around a stockpile and you will get an accurate volume every time. We have a workflow for convergence analysis as well. Like I showed, Connect does have a change detection tool in it, but some people like to use third-party softwares. As long as we can provide you a clean georeference point cloud in the right format, you can do all these applications with it. The critical part is obviously the georeferencing and the cleaning of the data. Another very useful application we have for our systems is the ability to scan vertical shafts, be it ore passes or vent shafts. We can scan that. We've got some very good user cases where people have done that, and there's been quite a lot of deviation from the original profile due to geotechnical activities. A lot of people are doing this. The longest scan I've seen is about 900 meters deep. So they've turned the scanner on and simply dropped it down this vertical shaft. This was a vent shaft, and we had an accurate model come out of it at the end. Very nice, simple workflow there, and it's a very effective data that all mines should have. All mines should be monitoring their vent shafts. And then simply, like I've shown before, production progress mapping. Again, only possible because we can now georeference our data. Very, very effective tool, this. And it's possibly what most of our mining customers are using it for, just to try and understand how much has been excavated from the shift before. Nice, simple workflow. It's all on our website, and please feel confident that we have a lot of customers currently using it for exactly this now. So just to conclude, we do offer a demo in a box service where we can literally send you the hardware and the software to use for a few days. We're very confident with how our systems perform, and we just really want you guys in the field to pick up the scanner and carry out this kind of data collection. So we really encourage that. So go to our website, and then there will be a link there for demo in the box. We have got distribution networks set up around the world, so rest assured we will be able to get a scanner to you. And please follow our social medias. I'm quite active on LinkedIn. I like to share some of our more recent scans, some of the cool projects we're working on. So please feel free to follow me on LinkedIn, Owen Howells, or please follow any of our social channels here. And just to finish off, thank you all, guys. Thank you for attending this short webinar where I've gone over how we can georeference data for the industries. If you have any questions at all, please ask away now. Or if you want to, you can just send an email to info@GeoSLAM. We have a lot of information on our website. Or please send them to my email, owen.howells@geoslam.com. So any questions now would be really appreciated. Yep, so we have one question here asking at what level of automation is GeoSLAM volumes. The only process that isn't automated is where the user has to walk or drive around the stockpile. As soon as that data gets onto the computer and Connect can see it, it's completely autonomous from there. You will just get a result then of the volume, being it the net volume, the net tonnage, delta variety, and we do factor in the bulk or specific gravity factor for individual stockpiles. Yeah, another question here asking about, can it pick up control points on the ceiling? Yes, it can, as long as we can get the scanner to it. What I do try and recommend to some mines is to install 3D control in an area where they can easily access the data. These newly mined areas doesn't have to be close to these 3D points, as long as they're in walking or driving distance. We can take off the scanner from the vehicle mount, georeference it quickly, go to your 3 points or 4 points to tell the data set, give it its transformation, and then we can drive down in that same scan or walk down to the mined areas, and that'll all be georeferenced then. And yeah, another question, is this webinar going to be available afterwards? This is all recorded. I think we're going to send an email out after this with the recording of this. For our dealer network, if there's any dealers on this will also be on our on the dealer portal. It'll go on there, along with all the rest of our GeoSLAM mining webinar series and our other segments as well, be it construction and so forth. Got one more question here. Can you fix control points without the base plate? Yes, you can fix the control points without that. The base plate is attached to the scanner. That will just have our set offset then to our to the scanner. So it makes it a lot simpler to do it with the base plate and our other mounting options like the vehicle mount and the backpack systems. You can still have the reference point, the reference plate fixed to it. It could just slip in into the V mounts that we created on the back of the scanners. So yes, you can fix control points without the base plate, but we don't really recommend it. It's a lot simpler of a workflow without that. So yeah. Another question you're asking about Connect, can we use Connect now? Connect is going to be released in the next couple of months. Connect will be taken over in quite a slow way from Hub. We are going to try and recommend people starting to use Connect instead of Hub. There's no extra cost for having Hub, as long as you're within maintenance of your scanner. Also, I think from September, all new scanners will be shipped with a copy of Hub and with a copy of Connect. So if you want the more automated workflows, you can go straight to Connect. If not, we will have Hub there as well, just to help with the transitional period over. Okay, I think that's the end of the questions. There's no more. We will send, if there are any more questions that I haven't gone over, we will send you an email with the answer in that as well. But for now, please have a look at the website, our new content on there. If you're an existing customer, log on to GeoSLAM Academy. There's more content there around these kind of new products that we're trying to release. Likewise for our dealers, we're always updating our dealer portal with these webinars, these presentations going forward. So again, thank you very much for attending this webinar. I really hope you've learned something new today about GeoSLAM, and I wish you all a nice end to the day. Thank you very much.